Hello and good morning. Let's continue our review here. It says draw the lines of symmetry. Well, the lines of symmetry are any lines that you can draw that will duplicate itself when you reflect it. In other words, you have one line of symmetry here, and you have another line of symmetry here. So if I fold this over, it will match. If I fold it over this way, it will match. If I do this one will not work because this point will end up over here somewhere. And this point would end up over here if you fold it along that line there. A circle has an infinite number, infinite, and you represent that like that. Infinite number of lines of symmetry. This one would be like that. This one would be like that, and this one would be like that. I'm going to say 3 on this one. Find the area of a circle. Well, actually, no, this is area of the shaded region. And remember how to do that. You take the whole circle, which is pi radius squared. That's the whole circle. And then you multiply it by some fraction. So the fraction here is 20 degrees out of 360 degrees. So it's part of a circle. And so what you're going to do is 20 times 3.14 times the radius squared, divided by 360. And let's do that real quick, just so we know. So that's 25 times 3.14 times 20, press equals, divided by 360. I get the area as 4.4 square inches. This one right here says find the circumference. Circumference is the distance all the way around. So that's going to be pi times diameter. So pi times diameter. The diameter here is 10. The area of the circle, the whole circle, is going to be pi times radius squared. And the radius is half of that. The radius is 5. Okay, make sure you know that. Find the arc length. Well, what you're doing is finding the outer part here, kind of like the pupil on your eye. Well, the whole circle is 360, so that's going to be 20 over 360, just like before. But instead of using area, you're going to use pi times diameter. And the diameter here is going to be 10. And there it is. So you're going to multiply these top numbers and divide by that bottom number. Make sure you know both of these. This is called area of the sector, and this is called arc length, how long that is. Remember, the measure, it's kind of weird, but the measure is 20 degrees. But the arc length is all of this. Let's just go ahead and work it. So 10 times 3.14 times 20, press equals, divide by 360. So the actual length is 1.7 inches. So from here to here is 1.7 inches. But the measure is 20 degrees. It's kind of weird, but that's the way it is. All right, remember that. Go back and study. Let's talk about our review here. I want you to turn to page 11. And we're going to pick up where we left off yesterday. So go to page 11. All right, on this page right here, they want to know transformations here. And so what we're going to do when we take a look at this is what is going to map this onto this? Well, that's a flip. That's going to be a reflection, a flip. Okay? On the next one here, well, let me think here. If you rotate 180 degrees, is that going to work? If you reflect it over the horizontal, okay, and then, let's see here, reflect it over a horizontal line and then rotate it 90 degrees. So a horizontal line would look like this, and if you reflect it, it's going to look like that, and if you rotate it 90 degrees, is what they're saying is going to work on this, okay? Now let me think if we can figure this out a different way. If you rotate this 180 degrees, it almost seems like that would work. I would leave that as a possibility. Reflection across a vertical line and then reflection over a horizontal line is what they have on this one. So if you reflect it over here and then you reflect it over horizontal is what they have here. I'm not real positive on that one, but I'm going to put a question mark on it. Let's keep moving. Which triangle is congruent to this one? And state the pair of sides that are congruent. Well, let's take a look. Find PQR. PQR is this one. So you want to find one that's congruent to it. This one looks bigger, so does this one. I would have to go with this one right here. Now you got to match up the sides. Now notice what they're doing. They're going from P to Q to R. So P to Q to R. All right, so they stay away from this one here. So they're going the long side and then the median sides. So the long side is here and the median side is there. So I'm going to say triangle D, E, F. Make sure you understood that. Okay, look again. They're going from the long side to median. You go from long side to median. Make sure you name it the same way. Let's keep moving. On this next one right here, let's see what we have here. State the pairs of sides that are congruent. Okay, so I guess we still have to come back to this one. So the sides would be this one over this one, those two over this one, and then the first and last would match up with the first and last. Okay, remember we did that before. Okay, so let's keep moving. All right, so on this next one here, let's read it. The vertices of this triangle are this. Under which transformation will it not be congruent? All right, so a translation 2 units to the right and down, it's still going to stay the same. If you turn it clockwise, it's still going to be the same. If you reflect it, it's going to still be the same. A dilation makes it bigger. Okay, so a dilation is going to either make it bigger or smaller. So that would be your choice right there. That's where it's going to actually change. Okay, let's keep moving. Number 5. Which transformation will always produce a congruent figure? Well, this one you're multiplying here. And when you're multiplying, that's a dilation. And the dilation makes it bigger. This one you're multiplying, this one you're multiplying, it would have to be A. Because A, you're only adding and subtracting, and you're moving it. You're not changing it. Okay? All right, number 6. A figure undergoes a translation, reflection, and dilation. Will the image be similar to the original figure? Why or why not? Okay, so the answer here is yes, it will be similar. Okay, it's not congruent. The sides are still going to be proportional. Okay, any number of rigid motions and dilations will always produce an image similar to the pre-image. Okay, the sides will still be proportional. The angles will still be congruent. All right, let's keep moving. We've got a little bit more here. Let's try this one. Which of the following congruent statements are true? All right, so you got to follow the pattern on this one right here, and you got to see what works here. So in this particular case, let's take a look. So the pattern, they say TR and AN. All right, so let's match that up. TR and AN matches. That's true. TI is the first and last, and that should be AG. That's true. Put a check by that. RI and NG. RI is the last two, NG is the last two. Put a check by that. TI is the first and last, so it should be AG, and it's not. So we don't want that one. Angle T is the first, and A is the first. Put a check. R and N is middle. Put a check. I and G is the last two. Put a check. A and N is the same diagram. Put a mark on that. We don't want that one. Okay, so make sure you have that. All right, last one. The image of triangle ABC after rotation 90 degrees clockwise about the origin is this one. Okay? So you're rotating this 90 degrees clockwise this way. Remember, if you draw a line like this, it should match up with this one, and that should be 90 degrees, and it is. Which statement is true? Okay? So if you take a look at this one here, and let's just think about it a minute. Which statement is true? Well, BC and DE, let's take a look at it. BC is the long side, DE is the short side. No. AB and DF. So AB is the short side and DF is the middle side. No. Angle C is matching up with angle E. Well, angle C has on this one the long and the medium. This one has the short and the medium, I think, or the short and the long. So I'm going to say no on that. Angle A matches with angle D. I'm going to say yes on that one. All right, and that's pretty much it. What I want you to do for the rest of the time is study, no electronics. Let's turn our attention now to MCR. All right, so for MCR class right here, you have to solve this for the given value. So in this one, you're going to divide by 6. So you're going to get x equals g over 6. This one, you're going to draw your line, and you're going to move this to the other side. Remember, the sign changes, so that becomes a plus xy plus c. And then you're looking for p, so you want to divide by m. When you divide by m, this is your answer. This one right here is a little different. Let me figure it out here. Put a 1 under here, cross multiply. So you're going to get GA is equal to 1 times all of that. This is going to be all of that because it's not going to change. Notice that you have A's here and A's there. What I would do is move this one to the other side. So I would say GA plus, and actually it would be a minus 2A because you moved it, is equal to 1. Then I would factor out the A. Now you were taught how to do that. So you're going to be left with G minus 2 is equal to 1. And then you're going to divide by G minus 2, and then you have your answer. So A is equal to all of that. And there's your work, okay? And today you have a worksheet. You're going to be working this. If you get stuck, I want you to ask for help. Remember, 4th period, to turn in those forms, make sure they're filled up completely. Today's the day you got to turn them in. Have a good day, and I'll see you in class.